This is section 5.3, Rational Numbers. We start this video by defining what a rational number is. Rational numbers is the set of all numbers that can be expressed in the form a over b, where a and b are integers and b does not equal 0. The integer a is called the numerator and the integer b is called the denominator. You probably know rational numbers as another name, fractions. Some examples: 1/2, 3/4, -5/3, and even 7 is a rational number because it can be thought of as 7 over 1. The first skill we're going to talk about with rational numbers is being able to reduce a fraction. A rational number is reduced to its lowest terms when the numerator and denominator have no common divisors other than 1. Let's take a look at a couple examples. "12/10 can be reduced because it has some common divisors. The simplest and smallest divisor is 2. 2 goes into 12 6 times, and 2 goes into 100 50 times. Well, 6 and 50 also have common divisors. Once again, you could use 2. 2 goes into 6 3 times, and 2 goes into 50 25 times. 3 and 25, the only common divisor that they have is 1. So we know that 3 over 25 is the reduced form of 12 over 100. Number 2, 130 over 455. Well, you need to come up with some common divisors. The first one that pops into my mind is 5. I know that each of these numbers is divisible by 5. So 5 goes into 130. Let's think about this. 5 goes into 13 twice with 3 left over. 5 goes into 30 6 times. 5 doesn't go into 4. 5 goes into 45 9 times with none left over. And 5 goes into 5 once. 26 over 91. Now we need to decide whether there are any common divisors in order to reduce this fraction further. If you think of divisors of 26, 2 probably pops into your mind right away, and 2 times 13 is 26, but 2 doesn't go into 91. However, 13 does go into 91. 13 times 7, 21, carry the 2, 91. So 13 is a common divisor of both 26 and 91. 13 goes into 26 twice, and into 91 7 times. So our original fraction of 130 over 455 can be reduced to 2/7. And our last example, 72 over 90. So again, we're looking for a common divisor. You should be able to tell that 9 goes into both of these because 8 times 9 is 72, and 9 times 10 is 90. So we can reduce 72 over 90 to 8/10, but that's not reduced all the way because each of these can be reduced by 2 to 4/5. All right, our next skill is converting mixed numbers to improper fractions. You'll recognize our examples as mixed numbers because it's a whole number mixed with a fraction. That's exactly why they call it mixed numbers. So the steps for doing this: we multiply the denominator by the integer and then add the numerator. Then place the sum over the denominator. Okay, so let's do this one step at a time. Multiply the denominator by the integer. So 5 times 3 is 15. And add the numerator. 15 plus 2 is 17. So 17. And step 2 says place the sum over the denominator. So we have the sum of 17 over the original denominator of 5. 17/5 is our improper fraction, and we call it an improper fraction because the numerator on top is bigger than the denominator on the bottom. Now let's do our second example, 4 and 5/8. So we know we're going to do 8 times 4 is 32. 32 plus 5 is 37, and we put it over the original denominator. 37/8 is the improper fraction. Next, we're going to convert the improper fraction into a mixed number. So step 1 says we're going to divide the denominator into the numerator. And then step 2, we're going to record the quotient with the remainder over the original denominator. Okay, so here we go. Example 1, 42/5. Divide the denominator into the numerator. 5 goes into 42 8 times, right? Because 8 times 5 is 40. So 8 times. There's 2 left over. So we record the quotient with the remainder of 2 over the original denominator of 5. 8 2/5 is the mixed number. 5/3, well, 3 goes into 5 once with 2 left over and put it over the original denominator. So 1 2/3 is the mixed number. All right, next. Any rational number can be expressed as a decimal by dividing the numerator by the denominator. This may result in a terminating or repeating decimal. All right, a terminating decimal is one that will have an end. A repeating decimal will be one that repeats digits over and over again. All right, so let's take a look at some of our examples here to understand what's going on. So we need to express each fraction as a decimal. So 3/8. So we're going to do 3 divided by 8. If you did this on a calculator, 3 divided by 8 comes out to be 0.375. And using the calculator to do these is perfectly fine. All right, number 2, 5/11. So we simply do 5 divided by 11 on the calculator. Now this comes out to be a repeating decimal. You would see on the calculator it's 0.454545, and those 4 5s just keep repeating. Now, instead of writing it like this with the ... what we do, you may remember the notation, we put a line over the digits that repeat. And in this case, both the 4 and the 5 repeat, so that line is going over both of those. Number 3, 7/8. Simply take your calculator. 7 divided by 8 is 0.875, another terminating decimal because it ends after that. All right, next we're going to convert terminating decimals to fractions. So terminating decimals can be expressed as fractions by understanding the place value of the decimal. Okay, so let's start with our first example here. 0.9, you have to remember how to say this actually correctly with the place values. Remember that the first place value after the decimal point is the tenths place. So we can say 0.9 as 9/10, and we can also write it as a fraction, 9/10. And 9/10 is reduced, so we do not need to go any further. All right, so in number 2, 0.86, we have the tenths place with the 8, and we have the hundredths place with the 6. So we could call this 86 hundredths. We can write that as a fraction. 86 hundredths is 86 over 100. Well, now we have to do some reducing. So let's think about this. Well, 2 goes into both. Let's see. So 43 over 50. And now we have to think about whether there are any common divisors with 43 and 50. So if you think about it for a minute, I think you're going to come up with the fact that there are no common divisors. 43 might actually even be a prime number. I'd have to think on that for a minute. But 43/50 is reduced to lowest terms. All right, so our third example, 0.053. So we have the tenths place, we have the hundredths place, we have the thousandths place. So we would read this as 53 thousandths, or 53 over 1,000. And of course we now need to try to reduce this. Let's see if there are any common divisors. And if you think about it for a minute, you're going to come to the conclusion that 53 over 1,000 is reduced to lowest terms. Okay, we're done converting back and forth decimals to fractions. Now we're getting into the math operations with fractions, skills that students very often need review on. So we're talking about adding and subtracting rational numbers or fractions here. Step one, you must remember that there has to be a common denominator when adding and subtracting fractions. Step two, put the sum or the difference of the numerators over the common denominator. So let's look at our examples here. You'll notice that each of our three examples on this slide already have a common denominator. It doesn't get any easier than this. Okay, so all we need to do in our first example here is add 4 plus 5, and we end up with 9, and we keep the common denominator of 9. Do not add the denominators together. So the answer to this, 9 over 9, well, we know 9 over 9 is 1. So 4 ninths plus 5 ninths equals 1. All right, our second example, 5 halves minus 1 half. Once again, we already have the common denominator, so we just simply need to take 5 minus 1, get 4. Keep the common denominator of 2. 4 divided by 2 is 2. 2 is our answer. And finally, 3/7 plus 2/7. Again, we have the common denominator, so let's add the numerators together. 5/7. It cannot be reduced. That is our answer. Pretty simple when you already have the common denominator. All right, so let's go to some examples where we don't have the common denominator and we have to get a common denominator. So 3/4 plus 1/6. All right, a common denominator is a number that both 4 and 6 go into, multiples of 4 and 6. So you need to think for a minute. 12 is a number that 4 and 6 both go into. So in order to make the 4 into a 12, we need to multiply that by 3. But we can't just multiply the denominator by 3, we have to multiply the numerator by 3 also. So if you notice, really what we're doing is we are multiplying 3/4 by a fancy form of 1, because 3 over 3 is 1. And in math, you can always multiply by 1. It's what we call the multiplicative identity. Now, to make the 6 in the denominator of 1/6 into 12, we need to multiply it by 2. Well, we have to multiply the numerator by 2. Also, 2 over 2 is 1. We're allowed to multiply by 1. So, we do our multiplication. 3/4 times 3 over 3 gives us 9/12. 1/6 times 2 over 2 gives us 2/12. Now we have our common denominators. 9/12 plus 2/12 is 11/12. And that is already reduced, so there's our answer. Second example, 13/15 minus 2/45. Think of a common denominator. Well, it just so happens that 15 goes into 45. So 45 can be our common denominator. We will not have to change the 2 over 45 because it already has the common denominator. How do we make 15 into 45? We multiply it by 3. So we're multiplying 13/15 by 3 over 3. That gives us 39/45 minus 2/45. Now we have our common denominator. We can subtract 39 minus 2, which is 37. we have 37 over 45. And our final example, the most difficult of the bunch. So let's take a close look here. Let's start in parentheses in the numerator. We have 1/2 plus 1/4. We need a common denominator between 2 and 4, and you should be able to quickly notice that 4 will be that common denominator. So we're going to multiply 1/2 by 2 over 2. So we get 2/4 plus 1/4. All right. Now let's go to the denominator. 1/2 plus 1/3. A common denominator of 2 and 3 would be 6. So we're going to multiply this by 3 over 3, and we're going to multiply this by 2 over 2. So we end up with 3/6 plus 2/6. Now we can add our fractions together. So we have in the numerator 2/4 plus 1/4. Well, that would give us 3/4. And in the denominator, we have 3/6 plus 2/6. That would give us 5/6. All right. Now this problem is not complete. We're going to stop here because the rest of the problem is division with rational numbers, which we're going to talk about coming up here. But I gave you this example to show you that sometimes the addition of the fractions is simply a piece of a bigger problem. All right, next we're going to talk about multiplying the rational numbers, multiplying the fractions together. This is quite simple. You simply multiply the numerators together and multiply the denominators together. So here we go. 5/7 times 4/9. We multiply the numerators. That's 5 times 4. That gives us 20. Multiply the denominators. 7 times 9 is 63. Now, of course, we try to reduce when at all possible. And in this case, it does not look like there are any common divisors of 20 and 63. So there's our answer. Second example, 1/3 times 9/11. Again, multiplying the numerators together. 1 times 9 is 9. 3 times 11 is 33. Well, in this case, it's pretty obvious that 3 is a common divisor. 3 goes into 9 3 times. 3 goes into 33 11 times. So 3/11 is our final answer there. And finally, we have 3/5 times 4. Well, you might be thinking to yourself, I thought we were multiplying fractions. Remember that 4 is written as 4 over 1, so it is a fraction. So we have our numerators. 3 times 4 will give me 12. 5 times 1, my denominators, 12/5. That is reduced to lowest terms. Finally, we come to division with fractions. Multiply the first number, or the top number, by the reciprocal of the second number, which could be the bottom number. All right? Now, the reason that I say top and bottom is because each of these examples could be written as such. 4/5 divided by 1/3. So now instead of having a left and a right, we have a top and a bottom. Right? Same thing in our second example. Negative 2/3 divided by 4 could be negative 2/3 divided by 4. So our left became our top and our right became our bottom. Okay, so that's why we did the top and the bottom mixed in there. All right, so let's do the problem as we have it written here. 4/5 divided by 1/3. So we're actually going to make a division problem into a multiplication problem. We're going to multiply the first number, 4/5, times the reciprocal of the second number. You may remember reciprocal is whenever we flip the numerator and the denominator. So 1/3 becomes 3 over 1. So now we've turned our division problem into a multiplication problem. We multiply the numerators together. We multiply the denominators together, 12/5. So 4/5 divided by 1/3 is 12/5. fifths. All right, next we have negative 2/3 divided by 4. Remember, 4 is 4 over 1. So we're going to take the first number, negative 2/3, and multiply it by the reciprocal of 4, which is 1/4. Now we multiply our numerators, negative 2, multiply our denominators, 12, and reduce, we get negative 1/6. So as you see, a division problem with fractions actually becomes multiplication by the reciprocal. All right, this has been section 5.3 on rational numbers. There's been a lot covered here. Go back and watch the video again if you need to. Pick out the parts of the video that you need to refer back to, especially the operations of addition, subtraction, multiplication, and division with fractions.